Okay, we're back, everyone. Well, we're going to actually make a target. It's called the clicker game, so we need a target to click on. If I press start, you'll see I have no target. Nothing's going on in here. So let's go ahead and make our target. First of all, I would like to go to the game function because that's, as you can see, this is green, right? This is the function that's going to draw our game. We have a different function for drawing intro. This is our function that draws our game. So all the code for that should belong in here. Except for things like variable declarations and setup code for things like setting the initial values for variables. So I'm going to go ahead and make a circle. I want a circle target. So I want to see a circle in there. So I'm going to make a circle. And I don't want to just hard code it. Like if I just type in like 400, 400, like it'll always be at 400, 400. So I'm going to need to have some variables. So I'm just going to leave, I'm going to just pick my variables right now, x, y, and diameter. That's going to be my variables. Now, where do I declare those variables? Well, it's going to be in the main tab at the very top. I have a section here for target variables. Eventually, I want to have a color palette too because I don't like the colors I've chosen. Not that they're bad, and don't feel bad if you're using sort of those bright bold colors as well. It's no big deal. But I think I'd like to pick some nicer colors eventually. But here's where I'm going to put these. So important to know that I'm going to use a float for x, y, and diameter. Diameter is debatable, but x and y are pretty good to choose as floats because we're going to have velocities that are possibly going to be speeds that are possibly going to be randomized, and that's going to mean that they're likely going to be floats. Okay, so that's the story there. So I'm going to go ahead to go back to the game function now. These variables are declared, but where is the circle going to be? Like I haven't given this, like I haven't said how big D is going to be and stuff. Where should I put that? Well, that's for the setup, right? Our one and only setup is going to set up all of our variables for every tab, for every screen. So I'll go ahead in here. I'm going to put a section just for the target setup or target initialization. And I'll put in here let's go ahead and put in x equals the center of the screen. Now I can see this is 800 by 800, so I could just type in 400. Y equals 400. And diameter I'll say is 100. This is fine, but if I ever decide to change my screen size, I'll have to go change these numbers as well. And that's not a big deal, but I'd like to introduce this idea of making code that automatically updates with your changes. This is a powerful idea that will save you work in the long run. It takes a little bit of thinking to make it happen, but it will save you effort. So if you are like me and are either lazy, is one way to describe it, or you just don't want to do extra work, then you can put in a little bit extra work now to save you a lot of extra work later on. This is just the beginning of this kind of thinking, and it's very powerful. This particular example is not that big a deal, but check it out. If I want to make it the center, I could do width divided by 2. Width is a special variable that always knows what your size is. The width is also a height divided by 2 as well. So if I run that, check it out. I'll have my circle right in the center. And if I change my size to like 400 by 400, I mean, notice that sucks. I can't see it anymore. Oh, I guess I need to make it bigger. So that's clearly not designed correctly anymore. Oh, I don't know what size I have to do. Yeah, there we go. But notice now, I still get my target in the center. So it's good to design for not like one exact size, but to make your code more flexible and auto adapt as things change. Because maybe you will change things later on. Anyways, I'll leave it at 800 by 800 for now, and I'll leave that as my code. Just the half of width and half of height gives me the center. Diameter, I'll just choose as 100 for now. Okay, so I'm going to go now, and we have a target. So that's great. Here's our target. I'll put some code here for a comment here to say display target. I might choose the different fill colors. Let's make it white, and let's make it stroke black. And let's make it stroke weight 5. Doesn't really matter. I'm just going to choose those. There we go. That looks good to me. And now I'd like to make it so that it moves. So the way you make things move, we've already covered this before in a couple of videos. Actually, we did it in the animation project, where we learned how to make something go across the screen, and we did it also in the advanced techniques, where we learned how to make something bounce off the screen. So the basic way of moving something, I'll put the moving code here. I'll just zoom in a bit. Is x equals x plus or minus some number. So if we do plus, it will move to the right, and if we do minus, it'll move to the left. The thing is, though, we don't want it to always be moving to the right or left. We'd like it to bounce and change direction. So to make that happen, I'm going to make a new variable for this, for how much we're changing each frame. I'm going to call it Vx for velocity in the x direction. And we'll also make a Vy. So that's going to be how we're going to move things. If we start, nothing will happen because, well, first of all, we haven't declared the variables. And even if we declare the variables, they have no values. So I'm going to go ahead in here. I'm going to put float Vx, Vy. And I'd like to say that these are target velocities. So velocities in different directions. So still doesn't move. That's because we haven't given it an initial velocity. So I would like to do that now. So I'd like to play a quick thought game with you at home. Or if you're in class right now, I'd like to just give you a chance to try this out. If I was to say Vx equals 10 and Vy equals negative 10, what direction do you imagine that's going to go at? So just think about what it means to have these as our velocities, given that we're going to be adding them to x and y. So we're basically subtracting from y, making it smaller, and adding to x, making it larger. So which way does it go? It goes that way. So why did it go up? Well, we're decreasing y, and we have the upside down y-axis, so it actually rises up. We're increasing x, so it ends up going to the right, because the x-axis is just the way it normally is. So that's hopefully not too surprising. Maybe I'll make it 5. 10 was a bit fast. So what if I make it 5, 0? What direction do you expect that to go? So let's take a look. The answer is straight down. There's no movement in the x direction, and we're adding to y, which will move it down. Last one here. Oh, Vx is negative 5, Vy is 0. What way is it going to go? What way? Did you say to the left? To the left? Yeah, there it goes. Goes to the left. Because 0 Vy means it's not moving up and down at all. And negative Vx makes it go to the left, just like how number lines work. So that's great. Now what we're going to do is we're going to choose a random number for this. So I'm going to choose a random number. I'm going to say it's between negative 5 and 5. This will only work if you made your Vx and Vy a float. So go back and check to make sure it's not an int. Same with x and y. They need to be floats for this. So this chooses a random number between this lower range and this upper range. So somewhere in between those numbers. And then you can get some random directions and stuff. Unpredictable. So there we go. If we run it now, who knows what direction it's going to go in? Oh, it went in that direction. If I run it again, making no changes, this time, oh, it went in that direction. Now we're going to go over here. Whoa, okay, different directions. So, we get some interesting different things going on there. So now we have some randomness in our project, so it's not so predictable where things are going to go. Okay, so all the work really is being done by this code, these 2 lines of code. These are infamous lines of code that basically control movement in any video game. If it's a 3D game, you'd also have z equals z plus vz, and it's very powerful. We'll be learning later on how you can turn this into gravity and all sorts of stuff, which is lots of fun. Okay, so there's our movement code. Last but not least, well, this is nice, but our target just disappears, goes off the screen. It's gone. See you later. So we want to add in some bouncing code. So we have to figure out how to detect a collision on the edge of the screen. So to do that, what we need to do is we need to be checking to see if the coordinates of the circle are hitting the edge of the screen. So what are the edges of the screen? So for this particular project, because we have size 800, 800, this is going to be x is 0, and this is going to be x is 800. the top is going to be y is 0, and the bottom is going to be y is 800. So we can check to see if we ever go below 0 or above 800 in either direction to see if we need to bounce. And the way we're going to bounce is just by changing the plus minus sign on our Vx. If we change it from positive to negative, it'll just go a different direction, or negative to positive for that matter. It'll just flip the direction it's going. So we're basically going to make an if statement where we're going to ask the question, hey, is x less than 0? Or, this is the OR operator, by the way. The key is right above your enter key. It looks like either a vertical line. It's like on the backslash key, and it's like you have to press shift. Either looks like a vertical line or like two little vertical lines stacked on top of each other. So it's called the pipe, as far as I know. So we'll see if x is less than 0 or if x is greater than whatever your width is. I'm just going to type in width because everybody has width. It doesn't matter what number you typed in, width will work. So now I'm going to add in what happens when we bounce. So if we hit the left or the right, all we got to do is say Vx equals Vx times -1. And that works because if it's a negative Vx, it's going this way, or I don't know, going to the left. If we hit the left wall, we want to now go to the right. So timesing it by -1 will make it flip around. And then we'll do the same thing if y is less than 0 or y is greater than height. So that means Vy equals Vy times -1. So if we start this, oh, it's so slow. I'm going to start again. It's one of the problems with random. We might get slow numbers. Hey, look at that. It bounced. It bounced right in the corner. But that's good. That means both of them are working. Let's see how this goes. Oh, it's looking so smooth. Looking so smooth. Yeah. Oh, what a weird bounce. It just picked numbers that get it to go right in the corner. So it's working pretty good. Hey, there's one last thing I want to say before we end this video. How come it's the center? How come the center is what's bouncing? Shouldn't it be the edge of the circle? So here's the deal. If we're checking to see if x is 0 or greater than width, less than 0 or greater than width, for the circle, the x and y is actually measuring the center of the circle. So if we want to do that, we got to actually check the collision with a slightly smaller rectangle. We don't want to see if the edge of the center of the circle is touching the edge of the screen. We have to like imagine a slightly smaller rectangle that's inside that it's going to collide with. And that's going to just be, by bringing in the borders, the top and the bottom by whatever the radius of our circle is. So the diameter of the circle is 100. So if we just add 50 to one side and subtract 50 from the other side, then we'll bounce not at the edge of the circle, not at the center of the circle, but at the edge. So I'll put in 50 minus 50, plus 50 minus 50. So this will work nicely now. We should bounce right off the edge of the circle. Oh, looks so good. Looks so good. One last thing though, what if we change the size of our circle? What if we decide later on, or maybe, spoiler alert, what if we have to select our size for our circle? That's going to be something we're going to do. If I make this 300, well, that's no longer going to apply. It's still going to, the center of the circle is still going to be doing the colliding at the sort of 50 mark. But why can't we make this so that no matter what number I choose, it just figures it out? We can. That's the secret right here. Instead of saying like plus 50 minus 50, let's not hard code this. Let's make this diameter divided by 2 and minus diameter divided by 2. Hey? Yes, this is getting to look a lot like algebra. Don't get me wrong, it's a little bit confusing, but this will make it so that no matter what size of target we have, it'll bounce off the edge. Check it out. Here we go. Boom. Hits the edge. Hits the edge. No problem. If I go and change this to 50, little tiny target, it hits the edge. So we've made code that automatically updates itself. It's almost like error-proof code. It's not 100% error-proof, but I can now trust that whatever number I put in, I mean, if I put in 400, I can trust that that target's going to bounce off the edge no matter what. So I'm free to adjust the size. It also opens up the possibility of us selecting a size, maybe having an options screen, which we will have later on, where we can use a slider to select the size of our target. So that's going to be that. So I hope you got a lot out of this video, and you now have in your game a lovely bouncing circle that moves and bounces and is adaptable to whatever kind of size circle you have, or if that size actually changes in the middle of the game, that code will still make that happen. All right. Hey, thank you so much, everybody. Have yourselves a good day.